Okay, let's start with the talk about creating a cryptovirus for Symfony2 apps. My name is Raul Fraile. I come from Spain. And well, a little bit about me. I am a software developer at ServerGrow, which is a hosting company specialized in PHP hosting. I'm a certified engineer and Symfony certified developer. And I'm now studying a master's degree in research in computer technologies, and I am focusing on cryptography and data compression. So I thought that would be interesting to apply those things about cryptography to PHP and especially with Symfony. Okay, this is something we'll talk about during the talk. We'll see obviously PHP, FAR files. We'll see a little bit about them. Symfony, even though if you don't know Symfony, I'll explain just a little bit so you can follow the talk. Hash functions, cryptography, Symfony kernel events, OpenSSL. Okay, first we define what cryptovirology is. Cryptovirology is a computer science field that studies how to use cryptography to design malicious software. Okay. It's closely related to ransomware, which is you get some kind of information or you destroy something, and you ask for money or for information to get the information back or to get what you deleted back. And also for private information retrieval. Okay, from the point of view of a hacker, it's always important to, they want to retrieve some information, but they want to do it safely. Okay, so cryptography can help here. And it was a fundamental twist in cryptography. Before that, cryptography was used to protect information, to hide what we don't want to share with the rest of the world. But here, applying cryptography to malicious software was a fundamental twist. We'll divide the talk in two main blocks. There will be a quick demo at the end of the talk. First, we'll see what is public cryptography, which is very important. We'll see how and why. And then some Symfony internals. It's also important to know how Symfony works internally, so we can attack in some different ways. Some hiding strategies for our virus, and at the end, protection strategies. How can we protect from this kind of attacks? Okay, so we're going to see how we're going to create our own cryptovirus for fun. Okay, only for fun. This is only for educational purposes. And a warning, this is not a real virus, it's just a proof of concept. Okay. Symfony is, I chose Symfony because it's what I know, but these same concepts could be applied to some framework, to PHP, whatever you want, even to plain PHP. And we assume that the virus is already in the target computer. Okay. We don't see how to inject that virus in the computer. I'm not a security expert, so this part probably would be done by a security expert. So, a cryptovirus, how we are going to create it? So the first step is, we are going to have the app server. In the app server, we have Symfony here, an application written in Symfony, and we already have the virus. Then we have another server, which is the server of the hacker. So once the virus is here and it's executed, it connects automatically to the hacker server and asks for a public key. We'll see in a couple of minutes public key cryptography. But the idea is that we get the public key, the hacker server generates a key pair with a public key, a private key. So it returns a public key and saves the private key. Then the virus, already with the public key inside, infects the Symfony2 application, and it could be done in many ways, but we are going to use Symfony kernel events and the bootstrap php.cache file. We'll see also how they work. And then once our code is here, we have access to database connection, user upload files, logs, whatever. So we can use that public key to encrypt that information. Once that information is encrypted, sorry. Once that information is encrypted using the public key, there's no way to decrypt it without the private key, which is in the hacker server. So we will need to get that private key, obviously paying some money. So once we have the private key, we can get back that information. Hacker can use services like Bitcoin to add an extra level of anonymity. Okay. That would be a ransomware attack. And we're going to see also the other kind of attack, the private retrieval information. Using the same code, okay, we have here the infected application. Imagine we have a login and password page in Symfony. This is done in a kind of special way. So if we know that we are attacking a Symfony app, we know how to get that information. So once that information is submitted, we can take it here and save it encrypted in a file. So if anyone, if the webmaster knows, see these kind of files, he won't be able to know what is inside because it will be encrypted. Then we will create a backdoor so the hacker server can connect and get the list of users encrypted, and using the private key they will be decrypted. Okay. We'll see everything in the demo. Now we're going to see the different parts, important parts to know how the virus works. First, public key cryptography. Who knows how public key cryptography works? Okay, lots of people. Okay, public key, and it's also called asymmetric cryptography, requires two different keys: a public key, so we can share that key with anyone, and a private key. We'll use most of the time. We'll use the public key to encrypt information. Okay. There are two ways. We'll see. We'll use the public key to encrypt information and the private key to decrypt it. Public key cryptography is based on one-way functions, which are called also trapdoors. These mathematical functions are really easy to compute in one way and really difficult in the other way. We'll see an example now. And this is important because it is believed to be difficult. What does that mean? It means that there is no known way to do it fast. It doesn't mean that anyone or any organization can have already a method to do it fast. And some of these one-way functions would be integral factorization, which is used by RSA. We're going to use it. Discrete logarithm and elliptic curves. So if we have Alice and Bob, and Alice wants to send an image to Bob, Alice have her own private key and her own public key, and also both, a different private key and a different public key. So Alice says to Bob, I want to send that image. So Bob says, okay, I'll give you my public key. Using that public key, you will be able to encrypt it, so only me will be able to decrypt it later. We can see this like a box with a padlock. Bob is sending a box, an open box, and an open padlock. Alice enters that image in the box, closes, and closes the padlock. So only Bob will be able to open the padlock with the private key. If anyone in the middle gets that information, get just garbage. So this is the factorization problem. Okay. For example, if we have P and Q and we want to calculate N, N is a multiplication of P and Q. So even if we use some big numbers, for a computer it's really easy to do it and really fast. In the other way, if we want to know that multiplication, the result, we have the result and we want to know what two numbers were used for the multiplication, we will need to factorize. And factorize is really complex for a computer and for a human. So it is slow. And slow means that there is no known way to do it in polynomial time. We'll use OpenSSL for the example, which is a general purpose cryptography library. And because we have an extension, PHP OpenSSL, so we can use it from PHP. Okay. We all know what happened with OpenSSL a few months ago. So how can we use OpenSSL from PHP? Imagine we want to create a key pair, okay? A pair of private and public key. We define an array. Well, that is not important now. We say that this is going to be the length of the key and the type, which is RSA. Okay? RSA uses the factorization. With that function, we get a key pair. Okay? We get that as a PHP resource. With other function, we extract that private key, and then we extract the public key. It is not complex, but it's okay. It requires a few steps. But if you use this in a function, you just want to use the function and get the pair. This is how they look. If you already configure Apache, for example, with HTTPS support, and we already know this kind of keys. And then to encrypt that information, we can use this function, which gets the data to be encrypted, the public key, and a reference parameter, so we will get the encrypted information here. Then to decrypt it using another function, we pass the encrypted information. This will be the variable when we will get the decrypted information and the private key. Okay. So for our purpose, always encrypt information with the public key and decrypt it later with the private key. So is everything clear with the public key cryptography? Any question? Okay.
Yeah, one question.
Yes.
So your virus will use the OpenSSL, OpenSSH library, so it adds a dependency maybe to the application.
Yes. The question is that the virus will use OpenSSL, so it is adding a requirement for the virus to run. And yes, it's a requirement. So you could do it from PHP manually, but it won't be safe at all. But for a virus, yeah, it could be a good way. So Symfony, who have used Symfony before? who haven't used Symfony before? Okay. Symfony is a framework for PHP applications. It's quite complex and quite flexible, so you can use the whole framework or you can use only some components. And inside, in every request, there are dispatched a few events. They are called kernel events. So every time a client sends a request, a new object of the request type is created. And then the kernel.request event is dispatched. There can be one listener or lots of listeners listening to this event, so you can use that information for something, or you can, for example, send a response to that listeners and end the execution. Then, when a response object is created, a kernel.response event is dispatched. So we can also use it for whatever. For example, we could use Google Analytics code in that event. It's not the best idea, but we could use it for that. Sorry. Okay. Once the response is sent to the browser, it emits an important event, which is kernel.terminate. We are going to use that event because for encrypting information, because we are going to encrypt user-uploaded files. So this may take time if there are too many files. So using that event, the client already has the web page, so we can do it later. This is especially useful for example, sending emails or post-processing information. Then, in the normal flow, it is kernel.controller event dispatch. And then, in case we don't return a proper response object in the controller, there is like a last opportunity to convert that object, for example, one string into a proper response object. And always, in case there is an exception, an event is dispatched, so we can transfer that exception into a proper response object with extra information, for example. So we will use this event for encrypted information and this event to get the user and password entered by a client. Okay, a quick recap. Kernel request as soon as the request arrives. Kernel controller once the controller is resolved. Kernel view in case the controller does not return a response. Kernel response. Kernel exception, and terminate, as I said, for expensive poor response jobs. And the other part of Symfony that you need to know is the Bootstrap PHP GZIP file. This is a file created by Symfony. It is created by, it's a composer script, okay? But it is used to improve performance. This is just a huge file with lots of classes and interfaces. It's just a copy-paste of those files. Why? Performance, okay? Instead of loading those files separately, we already have here, and we are going to use them for sure. So it's a good idea to have them there. If you download the standard edition of Symfony, you will see these two commands. So when we do a composer install or composer update, these commands will be executed and create that Bootstrap file. Yes?
The bootstrap.cache file is generated by PHP or by the composer call too?
It's
Because you talked about the .cache file.
yes.
Okay.
It is generated here.
Okay.
Okay. The command is configured in Composer, but it is a bundle of Symfony, so it is created there.
It was just the question which if the web server has write permissions to the .cache file, but if the server is properly configured, it's not necessary, right?
You can use. Okay, the question is if you can use the Bootstrap file or not use it.
No, the question is if the web server needs write permissions to this .cache file.
Yes, it needs. Okay, but if you're using Symfony, they are probably there, the right permissions. It's not necessary to use it also. There are other ways. So we'll see the third part, hiding the virus. Usually antivirus software work in two different ways. The first way is through virus definitions. So virus definition, they are just patterns. So we can look for those patterns in files. Okay. It is fast because it is just to compare a few patterns, but it is only useful for known malware. If there is a new virus, we won't have the virus definition, so we won't get it. So the other strategy is to use heuristic. Heuristic are also patterns, but you look for suspicious patterns. For example, suspicious TCP/IP packets, suspicious kernel events. For example, a virus by definition replicates itself. So this is not a common. This is not common for normal software. So this could be a flag. So that could be a virus. Okay, I had to try this, but this works in PHP. Okay, you can do a link of the file, so the current script will be deleted. So this could be a good way to infect the Symfony app, and once infected, remove the file. Okay. We'll need to inject some code into Bootstrap file, as I said. So we can inject it as a normal PHP code, or we can try to make it difficult for a virtual antivirus to detect it. So for example, if we want to inject that code, PHP info, we can use this technique. There are other techniques. So for example, we encode with base 64 5 times. Base 64 is lossless. So once decoded, we'll get the same information. So we encode it 5 times, and then we generate a PHP code able to decode it. So we'll use eval, which is nice for a virus, for real software. And we'll inject this string, base 64 decode, 5 times. The encoded code will go from here, and then the 5 parentheses. Then we can use GZIP to compress it. GZIP is also lossless, so then we will be able to get the original information. So we'll get a compressed code. Then, using this, we'll be able to execute the code. We'll see an example also with this later. That is nice, but it's just a couple of tricks. So a better idea is use polymorphic code. Polymorphic code uses a polymorphic engine to mutate code. So we pass some code, and we get different code, but does exactly the same. So that makes it really difficult for antivirus software to recognize the code as changes every time. So most of the time you're forced into that antivirus software to use emulation, okay, to execute that code in a sandbox environment to see what it's doing. For example, if we have these 5 lines of code, all these lines print the same. Okay? They print hello world, but they do it in different ways. For example, the first one is easy, this one also. The fourth one uses the std out to print it, and the fifth one uses character by character. So all of them print hello world, but using different code. Using this, you're making life more difficult for an antivirus. And more important, in PHP, it generates different opcodes. So if you take a look at the generated opcodes, okay, they are all different. So it makes it difficult. The goal for a virus would be to create a polymorphic engine able to generate different code in each injection, in each infection. As you know, that this is also really difficult in a computer because it is impossible to generate real random numbers in a computer. If you use run or empty run to do cryptography, don't do it. Okay? You can see that there are patterns. Even in empty run, there are also patterns. It is better, but not good enough for cryptography. So it is always recommended to use physical methods for that. For example, random.org uses atmospheric noise to generate random numbers. And we also, as humans, are not good to generate random numbers. So we're going to do a quick test. During 5 seconds, we're going to think about one number between 1 and 10. Okay, start. This is real time. So most of you probably have think of the number 7, because our brain, when it tries to generate a good random number, it says, well, 1 and 10 out because it's the first and the last, second is too common, and then looks for, okay, it says the 5 in the middle, out, and 7 is what we consider the weirdest one, okay, because it's an odd number, it's prime number, okay, but an ideal pseudo-random number generator, this is the frequency that it should have. Okay, and the last part is about protecting us. So before the infection, we do what we're used to do. Okay, the usual security measures, restricted permissions. As you said, disable PHP OpenSSL if you are not going to use it. Okay. And something that we can also do is virus inoculation. For example, a virus always have a method to see if a given file is already infected or not. So if we know how to check, how the virus checks if the file is infected, we can inject that information, for example, in a PHP comment or using the HAL compiler function, and inject that information there. So if we know the virus and we want to avoid that attack, can be a good strategy, but only for a given virus. And once that the app has been infected, we want to check the integrity to know if it's infected or not. So one way to check the best way to check the integrity of some code, of some information, is using hash functions. Hash functions, we are used to use it in every day. We use SHA-1, for example, MD5 sometimes. And basically, they create fixed length digest, checksum, from data or arbitrary length. They must be easy to compute, and there must be really difficult to generate a message with a hash that we want. Really difficult to modify a message without modifying the hash, and really difficult to find two different messages with the same hash. This happens because the number of hash numbers is limited, but it must be really difficult. And the basic idea is this: okay, tiny changes in the source generate big changes in the digest. So, for example, if we are hashing 1 gigabyte of information, and we change just 1 bit, if the hash function is good enough, it should generate a new hash number with at least 50% of information change. If you like, the chaos theory is like this, like the butterfly effect. In initial conditions, little changes in initial conditions lead to big changes in at the end. Okay, so the theory says that the flapping of the wings of a butterfly could cause a twister in the other part of the world in many years. Okay? Like when you go to the past and they say don't touch anything. Okay? That's the same idea. Why we don't use MD5 anymore? Okay? Because it's not collision resistant. Okay? What would be the idea is in the build process, when we deploy the project, we can create a hash of the whole project and then check it regularly. For example, using the finder component of Symfony, we can get all PHP files, for example, and then create a hash of the whole project. So, using that number, we can check it in production from time to time and check if anything changes or not. That could be a nice way, but we already have this in PHP using the FAR extension. Okay. Anyone have used FAR before? Used? No composer? Okay. So the basic idea is you encapsulate all the project, even its dependencies, in a single file, in a FAR file. It's equivalent to the Java jar files. And the nice thing for this talk is that FAR files can contain a signature, a checksum, of the included files. So we are, sorry. Okay, so can contain a signature of the included files. So we can have what we did before manually, we can have it automatically. FAR files are divided in 4 blocks. Okay? At first, there's a stub which usually contains some loader functionality. Okay, basically some code to be able to map between the included files and that PHP code. It always ends with this function, HAR compiler. Who knows what that function does? 2, 3, 4. That is a real PHP function, and what it says is to the PHP interpreter to stop. Okay? Anything that I put after that, it is not interpreted by PHP. So we can use it, for example, for install script, for example. Then we have a manifest. This is no longer a PHP valid code because we use this function. The manifest basically has the name of the included file names, some checking, the timestamp, size, okay, some binary flags. Then the actual contents. We'll have here our PHP code, our dependencies, and at the end a signature. Okay, so we can have a signature in MD5, SHA1 to 56 and 512. So I created a. There's only a missing line. I created a really simple FAR file. So you can see here, we open PHP, we execute map FAR, so we can map between, we can access the included files and echo hello world, and then HAR compiler. This is the start. Okay. Then there's the manifest, which is all of this, which is basically some flags. This is also a manifest. This is the file I included. Okay, I included a file called 1.txt. Then the file contents. So the file has some random text inside. And then the signature. This is a SHA1 signature. The signature flag, which indicates the kind of signature we use. And a magic number indicating that there is a signature. So what happens if we are really smart, and say, well, we're going to change hello world by hello there. So our virus, for example, would do something like that, change code. If we try to execute that FAR, we get an error that has a broken signature. So automatically, PHP is checking that for us. What happens if we are even more smart and we change that little bit that says if there is a signature or not? If we try to execute it again, we can do it before it doesn't have a signature. Is it mandatory for FAR file to have a signature? No, it is not. But by default, in the php.ini file, we have this line. So FAR files are required to have a signature. Okay. So packaging a whole app into a FAR file could be a good idea to avoid this kind of attacks. And then, yes.
If the attacker can write the FAR file, he also can recalculate the signature and write it too.
Yes, that could be if you are even more smart. I tried to do it. I couldn't, but I need to spend more time on this. So let's see in action. Is there any question before seeing the code? No? Okay, I downloaded a Symfony project. The Symfony, there are a few demos and I am using that demo. In that demo, you have a simple page like this and a simple login form here. Can you see it at the end? Yes? Okay. Okay, this is the Bootstrap file. So, as you see, it's a huge file containing a copy-paste of common Symfony classes and interfaces. It uses the special way of using namespaces. You can have several namespaces in the same file using this notation. And what we're going to do is inject some code here. So as I said, there is a server, the hacker server, which will provide the public key. So this is the script. Okay. As we do it before, this is the only thing that changes. Okay, it generates a SHA-1 of the public key. This is only to have a kind of ID. So if that person pays the money, so we can, from that key, get the private key. We will save the private key here. Okay, and if I put content, save. And the response would be an array with JSON encode containing the ID and the public key. So we are serving the public key and storing the private key. Okay. In case it pays, we return the private key saved here. Okay. The Symfony project has a known structure. We could use any other framework, but as we know already Symfony, and we know that the upload file is here. So we have a TXT file containing hello world and an image. Imagine that these were uploaded by final users. So we are going to encrypt it, and in case they don't have a backup, they lose that information if they don't pay back. And this is the code of the virus. Okay, no clean code here. Basically, this would be a super polymorphic engine. So we are going to create a class because our virus is object-oriented. We're going to create a different class every time. So the name of the class would be V1, V10,000, V50,000, and we generate here the code. Basically, we have an encrypt function, we have a decrypt function, handle action, which depending on the request will do anything. Okay, and now the important part would be here. We are getting the contents of the Bootstrap file. Once we get the contents, we want to inject some code to be in the middle of the Symfony request. So what we are going to do is to look for this code. This is the code of the event dispatcher. And what we will do will be to maintain that code, but in front of this code, inject a call to our virus. okay, a call to the process method of our virus, which is static. And we will pass the event. So then, depending on the event, for example, the request event, we will do the struct user and password. In the response, just for testing, we will modify the response, adding an extra header containing crypto Symfony, you have PHAR, and the kernel terminate will do the encryption. Okay, we'll read the upload folder and encrypt all files. Okay, let's see in action. This one is commented because I don't want to lose the virus. Okay. So if we execute the virus, automatically connects to the hacker server, gets the public key. The public key is then injected inside the virus. So if we open the BOOTSTRAP file again, we have this code now. Okay. This code is only one big line, so it's more difficult to detect. This code is doing all of this. Okay. This code contains this class, the class we were generating. And we also changed some function calls. Okay. If we look for this, okay. For example, here the kernel terminate event, the normal code is here, but now it is injected this code. Okay, it's calling to the virus, the process method with the type of event and the event itself. So, if it does it in every request, because kernel terminate is executed in every request. So, if we refresh this page, okay, if we see the headers, here is the extra header we add. And if we see the files, we know that they are encrypted now. So if we find this and it's a project, we have a problem. I added this string at the beginning, so the file is not encrypted twice. And then in case we pay, we can execute. We have a script, we'll see now, and revert. So what we are doing now is sending the private key to the project. Demo effect. Just a minute. Okay, it is encrypted now. And it is decrypted. we are using the a backdoor to do this. So how the backdoor doors works? If you see the code is available online, so you can take a look later. Here, in every request, it gets some action. So in case the action is for revert that information, also it does the same, but in this case, reverting. Okay, and the last part, that would be the private information retrieval. We have this, okay, a simple login and password. So we say user FrOSCon, password 123465. It is not valid, but could be valid. And we can see in the cache file, and there's a new folder called users. I am saving them there. And there's a file, okay? We open the file, it's encrypted. So if anyone finds out this file, well, it could be deleted, but they have no way to accuse us for something, okay? Because they don't know what it is. They know that they are probably users because I named that way the folder, but I could use any name. Okay, if we say FrOSCon 2, 1, 2, 3, okay, we have two different files. And using the backdoor, we can get the users. Okay. It is downloaded the users, the list of users, and using the private key to decrypt it. Okay, they are there. Okay, FrOSCon 2, 1, 2, 3, and FrOSCon 1, 2, 3, 4, 6, 4, 5, 6. Okay, and that's all. There's the code of the virus. You can take a look and play with it, and send pull requests to make it even more stronger. Okay, thank you. Have any question?
So wouldn't it be nicer you as the bad guy have a public key and in the bad public key you do a virus code and then create a public private pair on the server side of the attack system? They use the private key, then you throw it away. Then you encrypt the private key on the client system with your public key, and then for getting unlocked, he has to send you the encrypted private key, and you're the only one to encrypt it. So you don't have to go to an outside server. It's only in the ransom process that you have.
Yes, that's a way, but you need that the client machine allows to do that. You're adding an extra dependency. That machine must have a proper pseudo-random number generator. But yes. Yes.
And a second question or a second recommendation, I don't think it's a good idea to delete or to encrypt the whole data at once. I think it's much better to encrypt it incrementally, so you have a longer time until the action, because like this is now, you just go back to the last backup and that's it. But if you make the data dirty over time, it's really, really difficult.
Yes. It is nice to think of from the dark side sometimes. You learned a lot. Any other question? So thank you.